Hi, this is Alex from devstories.eu. PySpark Fundamentals, Episode 8 of 21. A simple string value hiding in an integer column can bring a 1,000-node cluster to a grinding halt. You need a reliable way to enforce correct data structures and pick exactly what data moves through your pipeline, which is why we are looking at typecasting and selection today. To manipulate data in PySpark, you must first understand what a column actually is. A column instance is not a physical array of data loaded into memory. It is a lazily evaluated representation of an expression. When you reference a column in your code, you are not touching the underlying data. You are simply adding a step to Spark's logical plan. The data only moves when an action is triggered later. To retrieve and shape this data, you use the select method on your DataFrame. You have two main ways to tell the select method which columns you want. The simplest way is to pass the column names as standard text strings. If you pass a string to select, Spark returns a new DataFrame containing exactly that column, completely unchanged. This works well for basic extraction, but it offers no room for modification. To modify the data during selection, you must use column objects instead of strings. You access a column object by referencing it directly from the DataFrame. You can do this using dot notation, such as dataframe.age, or by using bracket notation with the column name as a string inside the brackets. Bracket notation is especially useful when your column names contain spaces or special characters that would break standard dot notation. This is the part that matters. When you pass a column object into the select method, you can attach methods to it to transform the data on the fly. One of the most critical transformations is type conversion. Data often arrives in the wrong format. For instance, you might receive numerical metrics formatted as text strings. To correct this, you use the cast method. PySpark also provides an alias called asType, which executes exactly the same logic. You call the cast method directly on your column object inside the select statement. The cast method requires one argument, which is the target data type. You can define this target by passing a string representation of the type, like the word int, or by passing a specific Spark data type object, like integer type. Here is how this flows in a real script. You call the select method on your DataFrame. Inside the parentheses of that method, you reference your target column using bracket notation. Right next to that column reference, you call .cast and provide your new type. When evaluated, this returns a completely new data frame where your selected column is now safely converted to the specified type. The original data frame remains entirely untouched because data frames are immutable. The key takeaway is that typecasting in PySpark is not a standalone process applied to an existing dataset in place. It is a lazily evaluated column expression, inherently tied to the act of selecting data to build a new, strongly typed data frame. If you enjoy the podcast and want to help support the show, you can search for DevStoriesEU on Patreon. That is all for this one. Thanks for listening and keep building.